Three-dimensional vectors. First thing that we have to get used to when working with three-dimensional vectors is the three-dimensional coordinate system. And for that we need three axes. We know two of them already. We're used to working with an x-axis, which is the horizontal axis. I'm now going to draw in a vertical axis, and I'm going to draw in an axis like so. Now this is supposed to represent a three-dimensional space. This axis here is the y-axis, and the one that comes up is the z-axis, and this here is the origin where the three axes meet. Now, this can be a bit tricky to visualise. Imagine you're sitting at your desk in a maths classroom in school. The left-hand front corner of the desk. So you've got, use your desk here. So the left-hand front corner, that's the origin, that's where the three axes meet. Now, imagine running your finger along the front edge of the desk in this direction here. That's the positive x direction. Keeping your finger on the desk, then imagine moving your finger into or along the surface of the desk into the main part of the desk. That's the x direction, positive x direction. That's the positive y direction. And the last thing I want you to try to imagine doing is moving your finger up off the desk into midair. And that's the positive z direction. So along the front edge is the x direction, into the surface of the desk is the positive y direction, and then up out of the surface of the desk is the positive z direction. Now, we don't, for the moment, work with negative coordinates in 3D. So the first thing that we're going to do now is to learn how to read coordinates from a 3D diagram. So here is a diagram showing a cuboid, and we have the three axes, the x-axis, the y-axis and the z-axis. Now this diagram is turned around very slightly from the 3D coordinate grid which I showed you a few minutes ago. We know that AB is 6 units long. I'll put 6 here. AD is 5. A to D is 5, so you can imagine 5 in here. And A to E is 2. And what we want to do is to list all 8 of the vertices and write down their coordinates. So we need 3 numbers, an x, a y and a z coordinate. Now A is nice and simple. Here is A here. A is the origin, that's going to be 0, 0, 0. Here is B. Now, the first coordinate that we want is the x coordinate. I hope you can see that the x coordinate of the point B is 6. And what about the y coordinate? Well, we're not moving in the y direction. So that means that we have a y coordinate of 0. And similarly, the point B is not up off the page, so to speak. So the z coordinate is also 0. C, well, let's have a look and see. C is here. So how do we get from the origin, point A, to the point C? Well, it's 6 along in the positive x direction. That takes us to the point B. And then what we want to do is to move 5 in this direction here. Remember, we know that A to D is 5, so all of these lengths here, B to C and F to G and E to H, they're also 5. So it's 5 in the positive y direction. And again, the point C is not off the surface, so to speak, so the z coordinate is 0. What next? We've got the point D. Where is D? Here it is here. So let's start at the point A. Now, this one, to get from A to D, we don't move any in the positive x direction, so it's 0. We move 5 in the positive y direction, and we're not moving up off the page at all, so the z coordinate is 0. Let's think about the point E. Now, starting at A again, we're not moving any in the positive x direction. We're not moving any in the positive y direction, but we are moving 2 spaces up. So that means that we have coordinate 0, 0, 2. And what about the point F? Well, so to get from A to F, we move 6 in the positive x direction. We move 0 in the y direction because we're not moving along the y-axis at all. And then it's 2 in the positive z direction. I hope you can see that the points G and H have the same z coordinates, which is to say 2. So the point G then, here it is here. So that's 6 in the x direction, that takes us to B. 5 in the y direction takes us to C. And then 2 in the positive z direction takes us to G. The last one we've got to do then, starting at A, that's 0 in the x direction, 5 in the y direction, and 2 in the positive z direction. Here's a second example. What we have here is something called a square-based pyramid. And we have the various dimensions. Now, we'll list there are 5 vertices, A to E. So have a look at the diagram and see whether you can work out what the coordinates of each point are. A is nice and simple. A is the origin, so that's going to be 0, 0, 0. How do we get from A to B? Well, I hope you can see that we move 2 in the positive x direction. We move 0 in the y direction. So we're not moving in this direction at all. And we're not moving up. So we have 0 for a y coordinate and 0 for the z coordinate. Now, if we consider the point C, so it's 2 in the positive x, 2 in the positive y, and again it's 0 in the z direction because we're not moving up off the xy plane, if you like, the xy surface. The point D, how do we get from A to D? We're not moving any in the x direction, but we are moving 2 in the y direction, and we're not moving any in the z direction. Now, the point E is the trickiest point. It's a square-based pyramid, which means that this point E here lies directly above the centre of the square base. So let's think about that. And we know that the height of the pyramid is 3 centimetres. So how do we get to the centre of the square base? Well, to get from A to the centre of the square base, we move 1 in the positive x direction, which is to say we move halfway along the line AB, so that's 1. And then what we're going to do is to move 1 space in here, which is half of the 2. So half of AB, and then half of BC, so that's 1, and then 3 up. Those are the coordinates of the point E. So what I have here is a 3D plotter, which I found on the internet. It makes it easier to plot 3D coordinates. It's kind of difficult to do that on a 2D surface like an iPad screen or a board or the surface of your jotter. So you can see we've got the x, the y and the z axes. I'm going to leave out the negative axes, the negative coordinates. That's a bit problematic for us at the moment. So I'm going to add my first point, and you can see what we've got here. So we can choose, let's choose an x value of 6, say. Now watch the red dot, which is centred at the origin just now. So 1, 2, 3, 4, 5, 6. And we'll have a y coordinate of 7. So we're going to move in this direction here now. So 1, 2, 3, 4, 5, 6, 7, and the last coordinate will take us up from the surface of the diagram. So let's see, let's have a positive z coordinate of 5, 1, 2, 3, 4, 5, and just to show the path that we've taken, so that's 5, that was 6 in the positive x, 7 in the positive y, and then 5 in the positive z. So that point would have coordinates 6, 7, 5. This is an example that I'd like you to try. You can maybe try on a piece of paper, try it on your jotter, something of that sort. It's what we have here is a cuboid, and I'm going to give you the coordinates of the point G. The point G has coordinates 10, 5, 6. And what I'd like you to do is to list the coordinates of all the remaining 7 points. And I'll give you the answers to those tomorrow. Once you've tried this one, move on to the next slide. This is a second example. What we have here is a square-based pyramid. And I'm going to give you the coordinates of the point E. And the point E has coordinates 3, 3, 7. So I'd like you to give me the coordinates of the 4 points that make up the base. Remember, it's a square-based pyramid. Third example, what we have here is a triangular prism. And I'm going to give you the coordinates of this point here, point C. That's 4, 8, 4, 8, 0. And the height of the prism is 5. The last piece of information you need is that triangles AEB and DFC are isosceles triangles. That should give you all the information that you need.